Greetings, friends. Good to see you again. Glad you're here. Glad you made it. Look at these figures. I'm going to tell you that they are similar. I'm going to say that figure A, B, C, and D is similar to figure, what comes next? E, F, G, H. If we did indeed make that statement, that figure A, B, C, D is similar to E, F, G, H, there's a couple of things that happen. Namely, corresponding angles, they are congruent. Another thing that happens if you know for sure that the shapes are similar, this means that corresponding sides have the same ratio. Corresponding sides are proportional, that means, because a proportion is an equivalence of two ratios. Are proportional. So let's make a couple of statements that we know to be true. If you take AB from the first figure and you match it to the second figure, AB, you can see it in the picture, or more reliably, if you're told that these two figures are similar, you can see it in the name. AB is proportional, or has the same ratio as EF. So AB matches with EF just the same, in the same ratio, as BC here matches with FG. Again, you can see it in the name as well. BC, notice I'm pulling from the first figure on top and matching it to the second figure on the bottom. And this is also equivalent because it should maintain the same ratio there. Another pair of corresponding sides, we can match up CD to GH if we wanted to. Sweet. With this knowledge, this will help us find missing side lengths to figures if we know that they are proportional. Let's do an example. Okie dokie, humans. We've got two figures here, and if I told you that these figures, GOAT, is similar to LICE, cool. It means something mathematically, and it will help us solve for this missing side length x in figure GOAT. Since these figures are similar, maybe you could find corresponding sides, which the ratio of corresponding sides is proportional to another pair of corresponding sides. So it's helpful to find one complete ratio that you have an actual number for on the top and bottom. So looking at our figures, I can see that GO is proportional to LI. Or it should maintain the same ratio, I should say. And we should see it's proportional to another set of corresponding sides. Perhaps involve the thing that you're missing. GT corresponds to LE. Awesome. We can fill in values here. GO is worth 30, LI 12. GT is the X value that we're missing and interested in finding, and LE is 16. Sweet. Now we can come about the value for X by solving this proportion. Cross multiplication tells us 30 times 16 should be the same as X times 12, 12X. 12X is equal to, 300 and then 180, so 480? Is it? Divide 12 to get X by itself. There's X is equal to 40. Hooray! That's the missing side length. You can check yourself before you rickety-wreck yourself. Is the proportion 30 over 12 from the original picture, is the ratio of 30 to 12 the same as the ratio 40 to 16. I'll let you check that out. If you simplify each, they should be equivalent. So check that out. Moving on. Story time, kids. Gather around. You've got a cactus, and you've got a man standing next to the cactus. They're both perpendicular to the ground, so the cactus is growing straight out of the ground, and the man is standing perfectly still and tall and straight up and down, also perpendicular or right angle to the ground. The sun is at the same angle for both of these, the human and the cactus. So the shadow is cast in the same exact way. This means that you've actually got pseudo-triangles here that both have the same angle here, and the sun's coming from the same angle, so you should have the same angle up here, and you should have the same angle down here as down here. All of the angles are congruent, but just the size is different. That screams similarity. So we can treat these two ideas as if these triangles are similar. And we can use the technique called indirect measurement to figure out how tall this cactus is if we know its shadow length. I was about to write cactus there. Indirect measurement. So the height of the cactus should be matching up or corresponding to the man's height at 6 feet tall. And if we pulled from the cactus first, cactus, man. So the shadow length of the cactus is 5 feet, and the shadow length of the man is 2 feet. So by cross multiplication, since these things are proportional, the ratios of corresponding sides should be proportional if the objects are similar, which they are. 2 times h is 2h. Get h by itself by dividing 2, and you've got 15 equals h, which is the height of the cactus. Pretty crazy, pretty awesome. Okay, here's a couple of problems for you to do and show me tomorrow in class. In the first, you have a palm tree that casts a shadow of 80 inches, and the height is unknown. And then you have a human that has a height of 74 inches, casting a shadow of 26 inches. Your job to set up a proportion and solve. So I want you to show the proportion and solve for the height of the tree. For the second, what you need to do is understand that these two shapes are indeed similar. Be careful to match up corresponding sides and set up a proportion in order to find the missing side length in figure RYAN. It's a nice name. Good luck. Pause the video so it doesn't go anywhere, so you can do these two problems. Pause, 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 pause. Okay, we're moving on. Here we go. We've got actually two figures here, and maybe you can see them. You've got figure ABC, triangle, and you've got a triangle ASK. And we're being told up here in the information given that these two triangles are similar. Well, if our job is to find out the value of x, it looks like we're going to have some work to do. Now, this 36 is indicative of the measurement of side length AB. This 15 is for BC, and this 20 is the length of SK. All right, might we be able to find out a proportion that involves a ratio that involves this side length here of BS? Okay. If we take apart these two figures, you'll notice that ABC is this guy. And you have ASK as this one. where ASK, this is worth 20. Be careful. It's not all of this that's 36. It's some of it that's 36. And you also have the x to add with it. But in triangle ABC, side length AB is 36 indeed, and BC is 15. So if we wanted a proportion that involves BS, I don't think we can find that. But I do know that we have these two figures down here that we took apart. And we have a label for AB. We have a label for BC. We have some stuff written along AS, and we have some stuff written along SK. So let's explore a little further. Notice that BC, side length BC, matches up with side length SK. If we took from ABC first, let's take from it again and notice that AB matches up with AS. Perhaps there's some information we can use to solve for x here. The length of BC we can see has a value of 15. SK is down there at the bottom for 20. AB is 36, and now be careful. The length from A to S is not only this 36, but it's also x. So 36 and x. Okay. It looks like we're on our way to figuring out what x is if we solve this proportion. Be careful when you cross multiply here. You're going to have, what is that, 15 is multiplying 36 plus x, and it looks like 36 is multiplying 20. Cool beans. Doing some quick math here, 36 times 2 is 72 with a 0, 720 is equal to 15 times 36, I believe is 540 today. And don't forget to double rainbow here, 15 times x is 15x. And then you'd solve this like a regular equation. I'm going to skip a couple of steps for the sake of time. 15x, and then you've got 180 divided by, what is that, 15? And the result should be 12 is equal to x. Cool beans. It would be horrible manners if I didn't allow you to try one of these neat little problems. Let's start like this. Let's say that triangle FAS is similar to triangle FRT. Having that knowledge, perhaps you can set up a proportion using corresponding sides in order to solve for x, which is the distance from A to R. Reference the problem before in order to do this one. Number 3. I'll be checking for tomorrow. Good luck. Goodbye. Pause the video so you can still see this. See you later. Toodles. Bonjour. Aloha.